Alright guys, welcome to another episode of Research and Design Build. So I had one request when it comes to 3D printing as far as, how do you go from your part sort of concept into a 3D CAD modeling software, into a slicer, and then finally to the printer. So I wanted to take a very simple part and, so this is just sort of a spacer, a bumper that's on the bottom of a bar stool that I have. And so over time, it just sort of snaps off here at the base because it is a pretty small piece of plastic, and it gets dragged across a sharp ledge or something in the tile, and you will pop these off. So pretty simple piece, and I'm going to try to walk you through how you would replicate this using a set of calipers. If you don't have a set of calipers, even for something this simple, a ruler would probably be close enough to approximate things. And then, if you did really need to reprint them and change the dimensions, you could easily go back into the model and do that. So that's what we're going to do in this episode. So to get started, again, this is a pretty small piece. We'll probably end up printing this in PLA, although you could print it in pretty much anything for the application. It's going to be indoors, it's not going to be exposed to UV light, so your options are quite wide for what type of plastic you print it out of. PLA is probably the most common, cheapest, and easiest, and strength-wise it's pretty good. So we aren't going to replicate this perfectly, and that's because right down here at the base, this cut that goes, and I don't know if you'll be able to see it, but the cut that goes through the center goes all the way down to the base. And we're going to modify this a little bit so that it works a little bit better with 3D printing. Because 3D printing, we're going to print this with the bottom down. All the layers are going to be built up from there. And layer adhesion is pretty good, but that's kind of the weak plane. So if you think about it, having a bunch of pieces of spaghetti sort of piled on top of each other, they're pretty strong, the length of the, you can't really pull the spaghetti apart, but to slide one layer off the other or shear it is fairly easy. So that's going to be kind of our weak point. So what I'm going to do is I've already measured the bottom of the bar stool, and that's about 7.6 millimeters in diameter. And so that first couple millimeters that it goes into the bar stool, I'm going to have solid before I have this little slit. So a little bit of a change from the original design here. Is going to start with a sketch. And we're gonna, with all of the 3D CAD programs, you gotta pick which plane you're gonna start from. So we'll go off this bottom one. Doesn't really matter. We're gonna do a circle, and we're gonna come out here and we will measure this guy. So this one, diameter, is 25.08 is what I'm measuring. And we're just now 25.1. And hit enter, and now we've got our circle. Now we're gonna right click and we'll go to this press/pull. And so we wanna go up and just measuring off this one. Now this will be a more crucial dimension because this will be the one that you want to have equal for all of your others that are on the chair in this application, and we're exactly 4 millimeters. So we'll go up 4, and really on this piece, that's probably the most crucial dimension, other than the dimension of this part, which inserts into the hole in the bottom of the bar stool. So now we've got this bottom piece finished and done, and now we got to work on this top nub there. So our requirements for this piece, I measured the bottom of the chair earlier, and we get 7.6 millimeters in diameter, and then we had about 8 millimeters, just over 8 millimeters in height that we can work with. Now, on this one, they've only used about 6 millimeters of height, so we're gonna take those other 2 millimeters. We'll use those as well, just to help us out a little bit. So now we're going to select the top surface, and we're going to go up here to create sketch, and so it rotates to that plane, so we're looking in it. Your scroll wheel, you can scroll in and zoom in, and then we're going to draw our second circle, and so this is for that nub, and so we're going to go 7.6 millimeters. All right, so we're 7.6, and then right click, and we're going to press pull. Rotate. And we're going to go up, let's go up 3 millimeters. All right, so this will be the piece that sort of inserts in, gets our location, and creates our sort of stability or our strength out of that. Now we're going to do another sketch, and again we're going to go on top here. And we're going to go 7.6, press pull. And so we went up 3, so we're going to go up another 5 millimeters. We're going to go up. Go. All right, so now we got our total 8 millimeters, and we could probably skip that first 3 millimeter extrusion, but I wanted to do that just to show you guys that was going to be the solid piece. And now we're working on the other option. So now we're going to go kind of the other way. And we're going to do another sketch on here. And then this is going to be the relief, which allows us to kind of do an expansion for this top little bit here. So we'll just draw a rectangle, and then up here we've got sketch dimension. And we can pick between that and the center. And we want that to be and this looks like this is about 1.2, so we'll do 0.6 on this side. And 6 on this side. Right. That we want to do a press pull again of each of these 3. and we're going to go down the 5 millimeters. Hit enter. Now that's got us a slot cut right out of the middle. And then do another sketch here. Another circle, and we're going to do 8.25. Do 8.5. Little box here. Alright, so now we got the two sides here, and we're going to do a press pull, that and that, and we're going to go down, and for this one we'll just go down 2 millimeters. We're going to go down this way, -2. That's not what I want to do. Alright, that worked. For whatever reason on that side. Alright, so there we go. Now we got those two coming up. So that'll give us sort sort of this top nub here. We just got to put a chamfer on it. So you can go up here to modify and chamfer. And we're going to chamfer that and that guy. And we'll do 2 millimeters. Alright, so there's our finished part. Now we just need to save it. So this is one of my first times actually using using Fusion, sorry. Typically I use SolidWorks, so that's the one that's most familiar to me. There is a free student version of SolidWorks that you can get provided you sign up with them. There's also Onshape that provides one, and Fusion 360 is kind of the most common one that guys are using for 3D printing, as far as being a free software that you can access, provided you aren't using it for commercial use. So far, you know, if you're just doing basic stuff like this, any of them are going to have way more capacity than you're going to need to design the most basic of parts. All of these software suites are really designed for, you know, very high-end complex parts. You know, big manufacturers all over the world are using these sorts of softwares. There's also CATIA. CATIA, I know back in the day when I started using it, were really good with finite element analysis, whereas SolidWorks was sort of just getting into it. But all of these companies have really stepped up their game, and sort of the complexity of that business is quite extreme. So whatever you can kind of get your hands on, they're all going to operate under essentially the same premise of you picking a plane to start off of, and then you sort of building on that, and then being able to reference other parts of that object that you've built to then build other things off of that. When you get into some of the more complex shapes and that sort of thing, then things can get a little bit more complicated, and each program will have sort of its own way of defining a certain sweep path or otherwise, if you're making like a screw profile or something like that. But there's a lot of tutorials on almost all of the programs online on YouTube and otherwise to find out how to do that. So now that we've got this exporting, this is taking a little bit of time to export the STL file. Once we have the STL file, then we can switch programs, open up the slicer, which we're going to use PRUSA Slicer, and we can actually slice this part into all of its layers for the printer. Then we'll generate a G-code, and the G-code is basically the coordinates that control all the different motors that are on the PRUSA, as well as the extruder, and tell it sort of how fast to run the extruder and where to move all of the different axes. Very similar, or G-code is kind of the universal language of pretty much all CNC or computer controlled equipment. So even your big CNC lathes and mills would be running a G-code. All those guys that you see with laser cutters or CNC routers, CNC plasma tables are all running G-code as their sort of communication language, if you will. So you can learn to actually code in G-code, and historically, if you were machining a part, you would actually put in all of those G-codes in almost like a coordinate type fashion, giving the machine very specific instructions as far as speeds, feed rates, and where it was going to go and what path it was going to take to get there. So this is about 3/4 of the way through exporting for me, and once we get it exported, I will pull up the slicer and we will start doing that. Squared away here, we've got it exported. Did take a little longer than I was expecting as the first sort of file from Fusion 360 that I've exported. But again, STL is the file type you want to be exporting it to. So here in PRUSA Slicer, when you first open it up, this is what it will look like. And we want to import, and we're going to import an STL object file. And then I put it on the desktop, so there we go, there's our bar stool file, and there you go. So it is all ready, and again your scroll wheel kind of does the moving around, and your left cursor button does the rotation thing. Now it already put it down on the build plate with the orientation that we wanted it to. But you can click over here and rotate it if you want. Now, you know, we don't want to build in this geometry, and if you've got a more complex object, it won't necessarily put it down the way you want it to, so you can use these commands to put it down. So if you want to place on face, then you click on this guy and then click on the face, and there you go. Now we've got this on the build plate. You can also move it around the build plate if you're so inclined, so we can put it up here in the center if we want. So now we're going to get into really the nitty-gritty of it, and this is where you can take your part and you can have it as a 12-hour print, or you can have it as a 3-hour print sort of thing. Now this, just from knowledge of printing some in the past of a slightly different design, we should be able to get, you know, in and around the 10 minutes sort of thing. So we'll go up to here to print settings and go through the printers you want. So I was going to do this with a full 100% fill density. Filament settings is Prussian PLA, we're not going to touch that. And then you've got all of these other settings that you can start playing around with. You've got all your fill patterns. You've got your skirts and brims, so if you have a really small base on the object you want to print, you might want to increase this brim width. And then your layers here, we're going to print this with a 0.3 millimeter layer height and a 0.35 first layer height. And then the number of perimeters and the solid layers. So you come back here to the platter and hit slice now, and over here on the right it gives you 11 minutes for the total print, the total print cost of 0.07 cents, and or 7 cents I guess, and there you have it. You can use this guy here to sort of drag down, and here I'll zoom in a little bit and see the pattern that you're making on each layer and what that's going to end up looking like. So again, you'll have to play around with those print settings, especially for big models. This one doesn't really matter because you're dealing with such a small model, but this will be something that on a bigger model will make a significant difference as far as how much time things take to print. Now all that noise in the background is this actually already starting to print. So you just go to export G-code, save it to the little memory card that the PRUSA printer came with, input that in, and then right here I've got the video of me starting this last print. So right here on the left is just a regular memory stick that comes with it. We'll be exporting this G-code. To the memory stick. turn on the printer on the back here. And we're going to go print from SD. It goes in chronological order, so this is the one that we just selected. Now we do have the smooth build plate in here, which is recommended for the PLA. We've got our silver PLA already loaded, so everything's ready to go, and we've got a clean build plate. So now it is going into bed heating, and you can see here temperature of the nozzle heating up, and then what we've got our bed heating up to. So now we just sit back and watch it print. So guys, this is a really long video, but wanted to kind of show the whole process start to finish, from finding that part you want to print that you need for repair in this case, to doing the 3D CAD, to maybe modifying it a bit to suit 3D printing, and then getting that CAD drawing finished, saving that, moving into a slicer, and then finally printing it and installing your final part. So I did have to just do a little bit of sanding. I'd kind of made that nub a little bit too wide at the top. The PLA wasn't quite flexible enough to allow that to insert nicely. So a little bit of sanding got that clearance down a little bit, and it slid right into the hole with like a good solid fit. So you'll have to go back and forth and just make a small tweak to the model, and then your next print will be bang on. So hopefully you guys enjoyed this. I know it's almost a 30-minute long video at this point, but yeah, that's what it takes, and all of this is pretty much in real time. This is my first time using Fusion 360. I'd be a little quicker on the CAD with SolidWorks that I'm more familiar with, but you can really go from concept to a quick design to 3D printing and get a part out probably in 35 minutes, 40 minutes maybe, including print time for some of these smaller items that you might need to fix around your house. So hopefully you enjoyed that. I've got one more that I'm getting ready to print right now to finish off that bar stool, and then that project will be done. So please consider subscribing and check out some of my other videos on my channel. It would help me out immensely, and we'll see you in the next episode. Thanks, guys.